Okay. So there's two of them to go through. I'm going to recommend we do this one first because that seems like that's the big daddy.
Yeah, that's the one that I needed too.
Okay. All right, so find n so that we can get our approximation within that accuracy, right? So this really isn't, they don't even ask you to find an area estimate. They just want you to, which would be kind of a dumb question in a way because if you knew what the, I mean, you could just calculate the integral and then round it to that. What's that? This is the one that we needed to do. The other one we finished.
I just asked you if we went over it, and you said no.
The other, did we not finish the other one?
The table one?
The table one is on 4.6 and it shows you how to do it.
Stop getting mad at
You
me,
mean
please.
that one?
Yeah.
Oh, that one's, we'll do that one next. This
Okay.
is more important. Yeah, that other one just takes
Just
a second.
making
It's
sure
really
you weren't
easy.
lying to us.
No, that was lying. Okay, so on this one, they don't ask you to actually calculate the area, approximate the area. They just want you to know how many trapezoids would you need to calculate the area to that degree of accuracy, right? So that's, we're within that area. So we use the trapezoidal rule error formula and not the trapezoidal rule formula, right? So remember that one was, and I see if I can remember this. That was b minus a over 12n squared. Is that right? Do we have that written down? I think it's that. B minus a over 12n squared. Could be wrong though. So you want to check.
How do we check where we have it?
It's in the book, or it should in somebody's notes probably the other day.
Yeah, I think you should probably double check on that because I know I don't have my book.
I think that's right.
Let's hope it is.
Let's check. I didn't know you had to.
What is the line read?
Absolute value. Right. So we're finding the maximum on the interval from A to B. We're finding the maximum value of the absolute value of second derivative.
What is max? Is that
Wait, what is that?
It just means the biggest value it could take. So it'd be max. It's maximum.
But like in
Looks like
the
a
equation,
S.
notation.
That's notation. Yeah. Yeah. It means find the biggest value of this function. Like if you did that, like in programming, or say if you had a max function, it would just say you follow a bunch of a list of arguments. You pick the biggest one out. Same kind of concept, right? It's just picking the biggest value of that
I
function.
just didn't know if you could start writing words and things. I know we can start adding like sentences
What are you talking about?
in our equation. Well, you can't just add words in the math.
You're talking about the max?
That's the notation. That's how this is written down. You look in a textbook, and that's what it'll say. That means something.
So if you wanted second to largest, you just say second.
Well, that wouldn't be standard. You'd have to probably clarify that. But everybody would know what you mean when you said that. I'm going to double check to make sure
I'm
that's
going to go to
right.
math classroom and they'll see that and go, oh, I know.
Yep.
I know what's going on today.
You might have said, oh, cube. I forgot the cube. There we go. Okay. Okay, 12n squared. Yeah. Okay, good.
Why is it 12?
This off the little packet you have.
Just is.
The multiply is always that?
For the trapezoidal rule, yeah. That's the error formula for the trapezoidal rule. Okay, so now let's apply that to our situation. So we know what the error is, right? That's what's going to go. That's what this we're comparing this to.
So
What's B?
Two.
2. What's A?
Zero.
Okay, we're finding N. So what's F of X?
X plus 2.
Yeah, x plus 2 to the 5/8. So we need a second derivative of that, right? So what's the derivative? What's f prime?
What is it? X.
No, 1.
How do I differentiate that?
X
There you go.
plus.
X plus 2 to the
To the,
negative 3/8. Good.
like this.
And then times the derivative of x plus 2. But what's that? 1. Okay. So there's the first derivative. What's the second derivative? What's that your big?
Negative 15 over 64.
50 or 64 down, 1.5.
X plus 2. So that is negative 11.
Okay. So we'll want to write that as a fraction. Right? So we get negative 15 over 64. Okay, so then we're looking for the absolute value is going to make that take care of the negative side, right? We want the value to be maximized. Now the only variable shows up right there. That's the only thing we can control. So on our interval from 0 to 2, the argument of that power is going to go from 2 to 4, right? When x is 0, x plus 2 is 2. When x is 2, x plus 2 is 4. Which of those is going to make the overall fraction biggest? Do I want the denominator to be big or small if I want the fraction to be big? Small, right? So where's it going to be then? At x equals 0. Okay, so the maximum will occur at 0, and its value is going to be something bizarre that our calculator will tell us, though, right? So this is going to be maximum of the absolute value of f double prime of x on 0 to 2 is equal to what? We get positive 15 over 64 times 2 to the 11/8. Okay. Okay.
No, X. X is 0.
0.
The 2.
So
What?
if we're doing max, we only put 2 for X.
But if I put 2 in for x, then that's going to give me a bigger number on the bottom, which is going to make that quantity smaller, right? No, I put in 0, but then that gives me, if I see what I'm saying, that gives me 2 in there. Okay. Okay, so there's that number, and then everything else will be pretty easy. We know what b is, we know what a is. We're solving for n. So what does this expression become then? So we end up with b minus a is just 2 minus 0, right? So 2 cubed. So what do I get for my value? 2 cubed is 8 over 12 n squared. Right? I'm plugging in values for my air expression. Okay, times that weird thing we just calculated. Times.
Wait, explain to me where you're getting this.
Where do I get what?
It's just part of the equation.
That if I plug in b is 2 and a
okay,
is right. Okay, everybody with me? Okay. And then all this thing right here, we know becomes that. So I'll multiply by 15 over 64 times 2 to the 11/8. And that whole number we get in there, that error, has to be less than that, right? The error that we calculate. Okay. So how many zeros? 1, 2, 3, 4. 4 zeros, number 1. Okay. We can simplify that a little bit. 8 over 64 becomes 1 over 8, and 15 over 12 would be what, 5/4?
Wait, go back to that first page. Why is that greater and then
The error that we calculate from this has to be, that's kind of an awkward choice. That's how it always shows up, but it's, what we want is, ignore that for a second. What we want is the number that we're calculating. This represents the error, right? What this really means is that the error associated with the trapezoidal rule will always be less than or equal to the number that we're calculating here. Okay. Now we want, so that number that we calculate has to be less than 0.000001 because we need the error to be at least that, less than that, right? Does that make sense? Now, so what this is saying then is the error that this formula calculates, sometimes, depending on the function you're using, sometimes it might even be better than the threshold you're calculating, right? This is just telling us the maximum possible error. It might be better, but you don't ever really know if it is going to be better, so you better take the worst case scenario and just assume that they're equal, that the error equals this, right? So that number has to be less than our target, right? Target accuracy. Okay, so let's go ahead and maybe reduce this a little bit. So what do we get? 1, so 5 on the top, 32 times that thing on the bottom. So 5 over 32 times 2 to the 11/8 is less than that. Okay, let's go to the next page.
Where's that square?
What's that? Oh, n squared. Whoops. Forgot my n squared. Gotta have my n squared. That's the most important part.
Yeah.
We got the n squared also. I'll just put it there. So we got the n squared on the bottom, right? And that's what we're solving for. Yeah, track dismisses at 1:30, right. Okay, but we'll finish this. We're about done. Okay, so then why don't we just flip both sides, right? So we end up with then 32 times 2 to the 11/8 n squared over 5. If I flip both sides, it changes that sign, right?
Yep.
It's greater than 1 over 0.00001. And we could turn that, I mean, you could turn that into a number if you want to, but you're going to end up putting this in your calculator anyway, so it doesn't matter. So then to isolate n, we'll multiply by 5 and divide by all that stuff, right? So we'll get n squared is greater than 5 on the top, and then that times the bottom is going to be 0.00032 times 2 to the 11/8 to the 11/8. That looks bad. Right? And then we just square root both sides. And that's our answer. So let's go put that in the calculator, and we got it. Okay, so if we do that, Okay, so square root of square root of 5 divided by 0.123332. And I could have just said 0.00001 times 32 times 2 to the 11/8. Right? Enter. So 77.6. So what is n then?
78.
78. Right? Because we have to take the trapezoids in integer numbers, right? They come in increments of 1. You can't have a partial trapezoid. And so if we need at least that many, then 77 is not enough. So we better use 78.
77.
So 78 is, we want the minimum number. So the minimum number we would need is 78. More than that would work, but it would bog down the calculator more than we want to. Yeah.
Okay, so for track, can I go?
Yes. Track people, go. Go. All right. Okay, and then last one is this guy. This is a really quick one, right? Because all you're doing here, remember the trapezoidal rule, they're giving you the values of f, right? So then this is roughly equal to b minus a over 2n times f of 1, right, plus 2f of, or x of 1, sorry, plus 2f of x of 2, etc., plus the last one. Yeah. For which, you mean for like this one?
Yeah.
Well, because look, they're giving us the values. There's, see, what we have here. Here's x of 1, x of 2.
Okay, what about the ones you did yesterday? How do we know?
Well, you mean the one where we only have, if you have a ton of them, you got to use sigma. If you have a small number of them, you really get your choice. Do you want to use sigma or not?
Is this a small number?
Yeah, this is the easiest one you could possibly do because you don't have to do anything. They give you the numbers.
You have to do something.
Well, almost nothing.
They have to do it.
1, 2, 3, 4, 5, 6. So there's x of 7, right? So we've got, does that make sense? I mean, I'm sorry, that's x of 0 and x of 1. And that's x of 2, right? Up to x of 6. Now we start with x of 0. Right? So then we know that these are the ones, so here's f of b, right? Which is the same thing as f of x of 6. Here is f of a, which is the same thing as f of x of 0. And then these are the values of the function they get double.
Place of them 2 multipliers is 1 through 5.
Right. That's the interior sum. That's going to be, this guy right here, for example, is f of x of 1. This one right here is f of x of 2. So those are the ones that get double counted in the trapezoidal rule, right? Because we're adding up, we've got this multiplier times the first plus the last plus 2 times all the middle values of the function, right? So then all this ends up being, when we plug in the numbers here, we get 19 minus 1 over 2 times 1, 2, 3, 4, 5, 6. Right? That's n. That's the number of trapezoids represented. Times 12 plus 2 times 9 plus 2 times 8. See how we're getting this? Plus 2 times 10 plus 2 times 11.
What does it give us that?
Well, yeah, it does, because that's x sub 0. That's the starting point. So there's 1, there's
Oh,
1
okay.
delta x, 2 delta x, right? Delta x is just 3.
So on the equation there, the first x is 1, just get us a 0.
That should be x sub 0. Yeah. Plus 2 times 15 plus 18. Not times 2 though, right? We're only multiplying 2 times the interior ones. Those guys.
Wait, should it be 19 at the end?
No, we're taking the y values, right? So that's f. We're taking the y values. F of a, there's f of b, right? So that's the x value. We don't care about the x value, right? So that's our answer.
Wait, so it doesn't matter if the x value is going up by 3, we just count them as 0 and 1, 2.
Well, that means all that is telling us, if they're going up by 3s, is that delta x is 3.
Well, we don't need delta x.
No, we don't need it.
All right.
Yeah. Does that make sense? Okay. All right, let's go to 332.
Okay.
I hate that one.
Wait, leave it up.
I had to voice my opinion.